Ladies and gentlemen, hello and welcome back once again to Hot Technologies. Yes, indeed, my name is Eric Cavanaugh. I will be your host for another webcast today in this really fun, exciting series we've got. It's the complement to our briefing room series. The title is Application Acceleration, Faster Performance for End Users. And come on, folks, who doesn't want that? If I'm the guy out there helping your application run faster, I'm thinking I'm the guy getting beers bought for me at the bar after work. So it's got to be a pretty cool thing to walk in and speed up anyone's application. There is a slide about yours truly. Hit me up on Twitter at Eric_Cavanaugh. I always try to follow back, and I always retweet if you mention me, so feel free to mention me. So the whole purpose of this show is to focus on different aspects of enterprise technology and really kind of help define certain disciplines or certain spaces, if you will. So a lot of times vendors will pick up on certain marketing terms and talk about how they do this or that or some other thing. And this show was really designed to help our audience understand what a software tool needs to have in order to be a leader in its space. So the format is we bring in two analysts. They each go first, unlike the briefing room where the vendor goes first, and they each give their take on what they think is important for you to know about a particular kind of technology. So today we're talking about application acceleration. We're going to hear from Des Blanchfield and also Dr. Robin Bloor. We're all over the world today, and then Bill Ellis is dialing in from the greater Virginia area. So with that, I'm going to hand it over to our first presenter, Dr. Bloor. We tweeted the hashtag of Hot Tech, by the way, so feel free to tweet. Take it away.
Okay, well, thanks for that introduction. Application performance and service levels. This is a kind of an area, I've done a lot of work in this area over the years. In the sense I've actually done an awful lot of work in monitoring performance and working out in one way or another how to try and calculate service levels. But it has to be said that until, you know, we used to have this era a while ago where people built systems in silos, and basically the amount of work that you actually had to do to make a system perform reasonably well if it was in a silo wasn't actually too hard because there's very little, very small amount of variables you had to take into consideration. But as soon as we got properly networked, interactive, and service orientation came into the equation, it got a little difficult. Performance can be one-dimensional, and if you just think of an application executing a particular code path repeatedly, doing it reasonably in a timely manner, it feels like a one-dimensional thing, but as soon as you start talking about service levels, you're actually talking about multiple things competing for computer resource. And it becomes multidimensional very quickly. If you start to talk about business processes can be threaded together from multiple applications. And if you're talking about service-oriented architecture, then a given application can actually be accessing the capabilities of multiple applications. It suddenly becomes a very complicated thing. So I looked at it a long time ago. I drew this diagram. This diagram is at least 20 years old. Basically, I call it the diagram of everything because basically it's a way to look at everything that exists in the IT environment. There's really only four pieces: users, data, software, and hardware. And of course, they change over time. But you actually realize when you look at this that, you know, there is a hierarchical explosion of each one of these pieces. So hardware, yes. A hardware can be a server, but a server consists of possibly multiple CPUs. And networking, technology and memory and disk, and an awful lot of other controllers as it happens, and so on. You know, if you actually look at this, it all breaks down into pieces. And if you actually think about trying to orchestrate all of that in respect of data that changes, software's performance changes because the hardware changes, and so on and so forth, you actually are looking at incredibly difficult multivariate situation. this is the complexity curve. Of course, it's a complexity curve for just about everything, but I've seen this drawn time and again when talking about computers. Basically, if you put nodes on one axis and you put connections on the other axis, you end up with a complexity curve. And it almost doesn't matter what the nodes and connections are. So, you know, that'll do if you want as a representation of the volume growth in the telephone network. But in actual fact, when you're talking about nodes in the computer environment, you're talking about individual things that care about each other. You know, complexity turns out to be a matter of variety, structure, and the various constraints that you're trying to obey, and also the numbers. So when the numbers go up, they go crazy. I had an interesting chat yesterday. I was talking to someone, I can't mention who it was, but it doesn't really matter. They were talking about a site that had 40,000, that's 40,000 instances of databases in the site. Just think about that. 40,000 different databases. Of course, it wasn't the only thing they had. They obviously had many, many thousands of applications. We are talking about a very large organization, but I can't name it. You know. And you actually look at that, and you're actually trying to, in one way or another, get service levels that are going to be adequate across the board for multiple users with multiple different, if you like, expectations. It's a complex situation, and all that I'm really saying is that this stuff's complex. You know, the numbers always increase. The constraints are determined by the business processes and business skills, but you will have noticed the expectations change. Like, I remember as soon as Gmail and Yahoo Mail and Hotmail, all of those mail systems came out, people started to have an expectation that their internal mail systems within the organization would mirror the service levels of these huge operations with vast server farms outside the organization, and there started to be pressure to make all of that kind of thing happen. So, you know, actually, service level agreements are one thing, but expectations are another thing, and they fight each other within an organization. It's an awkward thing. Here's just a business perspective. In some systems, the optimal response time is 1/10 of a second. That's human response time. 1/10 of a second is the time it takes a cobra to bite you. If you're standing in front of a cobra and it decides to bite you, it's too late. It's going to, because you can't respond in 1/10 of a second. 1/10 of a second is about the time it takes for the ball to leave the hand of the pitcher and reach the guy with the bat. Basically, as he sees the balls thrown, he's got to respond at exactly that point in time. It's human response, kind of an interesting thing. Software to software can obviously have a higher expectation. And then you get into some situations which I think of as market situations where being first is where the business value is. You know, this is like, you know, if you want to sell a particular stock in the stock market, it's probably the best example. Because you think it's going down and a lot of other people think it's going down. You get the best price if you get to market first. And there's a lot of situation, ad serving and things like that, very similar situations. So you've got this movement in terms of service level expectation. You've got one thing is that there's a kind of glass ceiling for human response. So once it's software to software, if you've got this queuing situation, then there is no best service level. Faster than everybody else is the best. Okay, and this is, I think, the final slide that I was doing, but this is just to give you a big picture of the complexity once you actually look at an organization's requirements for service. You know, you've got, going up the left-hand side here, you've got system management, which is a set of software that serves into service management, which is trying to manage the service level. And above that, you've got business performance management. And then if you look down the bottom here, the service management automation, you know, you've got fragmented services that evolve into standardized services if you actually care to invest in this kind of thing, which evolve into integrated service, which evolved into optimized services. And mostly what people have done is only in the bottom left-hand corner of this, you know. Maybe a little bit of service management. Business performance management, very rare. Fragmented, nearly all of it, you know. And a perfect world would fill that grid. So, instrumentation. Mention the sub-optimization problem. You know, you can optimize part of a system and it's no good for the whole system. If you make the heart optimal, then, you know, your blood might circulate too fast for the rest of your organs. That's an issue with large organizations and service levels. Clearly, nothing's going to be achieved without sophisticated tools because the variables have just got, well, there are too many variables to try and optimize. So having said that, I'll pass on to Des, who'll talk about something else entirely, hopefully.
Thank you, Robin. So, like Dr. Robin Bloor, I have spent far too many years thinking about the performance of very complex systems at very large scale, probably not quite the same scale as Robin, but performance, it's a daily topic and it's part of our DNA to want performance and get the best out of everything. In fact, I've used a graphic of one of my favorite things in the world, Formula One car racing, where the entire planet sits still for a while and watches cars go around in circles very quickly, but every single aspect, there is no aspect of Formula One that isn't specifically about gaining performance. And a lot of people poo-poo the sport because they think it's a waste of money, but it turns out that the cars we drive every single day to drop the kids at soccer on the weekends and school the other days is derived from some performance-based development and research has come out of the likes of Formula One car racing. So everyday technology, everyday science often comes from the likes of something that has been focused purely on high performance. So the reality, though, is that our new always-on world, which demands 100% uptime, as Robin mentioned earlier with things like the introduction of webmail and other services we take for granted in consumer space, and we now expect that in our enterprise and work environments. The reality is that being up doesn't always mean that you're meeting your service level agreements. So I have this takeaway that the need to manage application performance and availability service level agreements has undergone a fundamental shift in the last decade. We're not just trying to worry about the performance of one system anymore. When the world was a bit simpler, we might have a situation where a single server running multiple services could be monitored live and it was relatively straightforward to support. You know, we could, and here's my little list of things that we used to worry about when I was a system administrator, for example, many years ago. And we'd look around and say, is the server physically up and responding? Can I log into a terminal, for example? Is the operating system responding and can I type commands? Are the applications up and running? Can I see processes in memory and doing things in I/O across disk and network and so forth? And in the mainframe days, we could hear tapes going zip, 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 and paper falling out of them. Are the apps responding and can we log in and do things on them? Are the users able to connect to some of those services? And it goes on, and they're fairly fundamental, you know. And then a few funny ones. Is the help desk ringing? Because if it's not, then everything's running fine, and who's going to get the donuts? Life was really simple in those days. But even in those days, and then I'm talking to 20, 30 years ago, the complexity was still really high. But we could relatively straightforward, in a relatively straightforward fashion, manage service agreements and keep an eye on performance. But we can't do it by hand anymore, as Robin alluded to. The challenges is too great. And the fact is that the time when a few good app admins, system and network and database admins could monitor and meet performance level SLAs is so far gone now that I struggled last night when I was putting my final notes together to even think of the year when I last managed to look at a system, a very complex stack, and make sense of it and even comprehend what was going on under the hood. And I come from a deeply technical background. So I can't imagine what it's like facing that on a day-to-day basis now in an administrative fashion. So what happened? Well, in 1996, database-driven apps were transformed with the internet boom, and a lot of us have been through that. And even if you weren't around the internet boom, You can easily just look around and realize that in everyday life that we hook everything to the internet now, and I've even got a toaster that apparently comes with the option to go to Wi-Fi, which is ridiculous because I do not need my toaster connected to the internet. In the 2000s, and particularly the early 2000s, we had to deal with this massive growth and complexity around delivering service and performance in the dot-com boom. And then another ridiculous upward spike in Web 2.0, where smartphones came about and now applications were in our hands 24/7 in an always-on mode. And it's 2016 now, and we're faced with another quagmire in the form of cloud, big data, and mobility. And these are systems that are just so large that they're often difficult to comprehend and put in plain English. When we think about the fact that some of the large unicorns that we talk about have tens, if not hundreds of petabytes of data. This is entire floors of disk space and storage just to hold your email, images, and social media, or in some cases, in air transport and shipping and logistics, or even banking. It's where your money is, or where your post is, or where your thing you bought on eBay is. And the next big wave we're about to face is this very heady challenge of Internet of Things. And as if that wasn't bad enough, we're about to build artificial intelligence and cognitive computing into just about everything. We talk to Siri and Google's engines these days, and I know Amazon's got one as well, and Baidu have one, but there's devices that we can speak to. They convert it to text. It goes into a normal system. The database makes a query and comes back and reverses the process. Think about the complexity that goes into that. So the reality is that the complexity of today's standard application stack is far beyond human capabilities. When you think about everything that happens when you push the button on your smartphone device or your tablet, you speak to it, converts that to text, runs that all the way over the internet to a back-end system. A front end receives that, converts it to a query, runs the query through an application stack, goes through a database, hits disk, comes back out, and in the middle there's carrier network, there's local area networks, data centers. The complexity is mad. So we effectively refer to this as hyperscale. And the complexity and speed of hyperscale is just eye-watering. Applications and databases have become so large and so complex that managing performance is, in fact, a science in itself, and many refer to it as a rocket science. We've got on-site technology, we've got off-site technology, we've got a range of data center options and physical and virtual. We've got physical and virtual servers. We've got cloud, where infrastructure as a service and platform as a service and software as a service are a thing now that we take for granted. The latter, software as a service, became scary for a while a few years ago when CFOs and parts of the organization realized they could pick up their credit card and just buy things themselves and go around the CIO, and effectively we call this shadow IT, and the CIO is now trying to wind this back and wrestle control back over it. In the infrastructure, we've got software-defined networking, network function virtualization. Below that, we have, or probably overarching that, we've got microservices and apps that act as services. When you click on a URL, there's a bunch of business logic that sits at the end of that URL that describes what it needs to actually deliver it. It doesn't necessarily have pre-built logic waiting there for it. We've got traditional databases on one side that is scaling very, very large. We've got the likes of Hadoop infrastructure and ecosystems at the other end of the spectrum that are just so large that, as I said, people are talking about hundreds of petabytes of data now. We've got complexity of mobility as far as devices to carry around go, and laptops and phones and tablets. We've got BYOD in some enterprise environments, and increasingly now, since the Gen Y experience, people are bringing their own devices and we just let them talk to them via web interfaces, either over the internet or over Wi-Fi, either free Wi-Fi in the cafe downstairs where they're having coffee, or our internal Wi-Fi. Machine to machine is ever present now, and that's not directly part of the Internet of Things, but it's also related. Internet of Things just is a whole new game. The complexity in that is mind-boggling. And artificial intelligence, and if you think that what we're playing with now with the Siri and other related devices we speak to is complex, wait till you get to a situation where you see something called the Ollie, which is a 3D printed bus that takes about 6 people and can drive itself around a city, and you can speak plain English to it and it will speak back to you. And if it sees traffic, it will decide to turn left or right off the main area where there's traffic, and as it turns and you get worried about why it's turned left or right off the main road, it'll say to you, don't worry, I'm about to turn left, there's traffic ahead and I'm going to go around it. Managing the performance of all the systems in there and all the complexity, tracking where that data goes, where it goes into a database, all the interconnects and all the relevant bits is just mind-boggling. So the reality is that managing performance and SLAs at today's speed and scale requires tools and systems by default. This is no longer something where we just think it would be nice to have a tool. it's a prerequisite. It is just absolutely necessary. And here's something just as a little example. This is the high-level application design diagrams for the OpenStack open source software-defined cloud. This is just the big chunks. This is not just servers and databases. This is where each little blue blob represents clusters of things, in some cases thousands of servers or hundreds of databases or if not more, tens of thousands of little pieces of application logic running. And that's for a small version. And it really is quite mind-boggling when you start thinking about the complexity that comes about in this. You know, today, even just in the big data space, you know, I would just put some screenshots of just the brands. When you think about all the pieces we've got to manage here, you know, we're not just talking about one brand necessarily. These are all the brands in the big data landscape and the top brands, not just every little small one or open source. And, you know, you look and you think it's quite a mind-boggling chart, but let's just have a look at a couple of verticals. Let's take marketing, for example. Here's a similar chart, but for the technology stacks that are available in marketing technology aligned. But this is the 2011 graph. Here's the 2016 version. Just think about this is just the number of brands of products you can run for technology with regard to marketing technology. Not the complexity of the systems inside there, not the different app and web and development network and all the other interconnects. That's just the brands. You know, there's the before 5 years ago, and here's today, and it's only going to get worse. So we're at this point now where the reality is humans simply can't ensure service level agreements. We cannot dive into enough detail fast enough and at the scale we need. And here's an example of what a monitoring console looks like now. This is sort of like nearly 20-odd screens glued together to pretend they're one great big projected screen, monitoring every little piece. Now, it's interesting in here, I won't mention the brand, but this monitoring platform is monitoring a single application in a logistics and shipping environment, just one app. You know, if you think about what Robin was talking about, where organizations could have 40,000 databases now in production environments, can you just visualize what 40,000 versions of this collection of screens monitoring one application could be like? Yeah, it's a very brave world we live in. And as Robin said, and I will absolutely 100% echo that, without the right tools, and without the right support and folk on the table using those tools, application performance is just it's a lost game to the humans, and it has to be done by tools and software. And with that, I will pass over to our friends at IDERA.
All right, Bill. Nice. Thank you. So I'm sharing out my screen here. And I guess, so could somebody confirm that you can see my screen?
Yeah.
Looks great.
Thank you. The one thing he referred to was that I really can't wait for is a self-driving car. But one thing that I hadn't heard anybody talk about is what happens when it snows. And I kind of wonder if the engineers in California realize that in other parts of the country it snows quite a bit.
I like that. I'm going to remember that one.
I bet they'll go 1 mile an hour.
So we're here to talk about application performance management in a complex environment. And one thing I like to talk about is a lot of people, when they talk about performance, the knee-jerk reaction is, you know, hey, more servers, more CPU, more memory, et cetera. But the other side of that coin is processing efficiency. And really, that's two sides of the same coin. And we're going to take a look at both of them. And the ultimate goal is to meet the service level agreements for the business transactions. I mean, ultimately, all of this technology exists for the business. When we talk about having an industry-first performance management database, the ideal of that is to kind of fit into the ideal mold of performance and managing it from the beginning of the application's life cycle. The topics are really boiled down to 4 pieces. One is the process of managing performance. We talk to everybody, and everybody has tools. If they don't have tools, they have scripts or commands. But what they're missing is context. And context is simply connecting the dots across the application stack. These applications, whether browser-based, are very tightly coupled from tier to tier. And so how the tiers interact is also vital. And then we're talking about the business transaction. So we're going to provide visibility not just for the technical folks, but also for the application owners and the operations managers. I have a couple of case studies to just kind of share with you how some customers have put this to use. So this is a very practical portion of the presentation here. So let's take a look at kind of what typically happens. I like the diagram. It was just like an incredible collage of technologies, because the number of technologies in the data center has just grown and grown and grown. Meanwhile, an end user doesn't care about it and is oblivious to it. They just want to exercise the transaction, have it be available, have it complete rapidly. What typically happens is the professionals in IT are unaware that end users even had a problem until they self-report. And that kicks off kind of a time-consuming, slow process, and often frustrating. What happens is people will open up their tools and they look at a subset of the application stack. And with that subset, it becomes very difficult to answer even the simplest question. Is an end user having a problem? What transaction is it? Where in the application stack is the bottleneck? And so, but by spending all of this time, looking tier by tier, not able to answer these questions, you end up spending a lot of time and energy, a lot of staff time and energy kind of finding out. So in order to solve this, in order to provide a better way, what Precise does is it actually takes the end user track transaction, captures metadata about it, follows that transaction through the network, into the web server, into the business logic tier, and we support .NET and ABAP and People Code and e-business suite, but in multi-tier applications. But ultimately, all of the transactions are going to interact with the system of record. Whether it's an inventory lookup, reporting time work, you always interact with the database, and the database becomes the foundation of business performance. And the database, in turn, relies on storage. And so what the metadata about the transactions answers: who, what transaction, where in the application stack, and then we have deep code-level visibility to show you what's executing. This information is captured continuously, put into the performance management database, where that becomes a single sheet of music for everybody to see what's going on. And there are different people in the organization that care about what's happening: the technical experts, the application owners, ultimately the business itself. And so when a problem comes out, you want to be able to extract information about that transaction. And before we get to look at the investing transaction, I want to show you how that might appear to different people in the organization. At a management tier, you might want to have an overview of multiple applications. You might want to know about the health calculated by SLA compliance and availability. Now, that health doesn't mean everything is 100% working perfectly. There is room. In this case, you can see the investing transaction is in the warning status. Now, a little bit deeper, maybe a line of business, you might want to have some additional detail about individual transactions, when they breached SLAs, transaction count, et cetera. The operations team would want to be notified about that through an alert of some sort. And so we have performance alerts built in, and we actually measure the performance in the end user's browser, whether it's Internet Explorer, Chrome, Firefox, et cetera. And so we are able to detect. So this answers the first question: is an end user having a problem? So let's dive in and see what else we can show about that. The people who are interested in performance would open up Precise. They'd evaluate the transactions. They'd look at the SLA column to identify transactions that were not in SLA compliant. They'd be able to see the end users that were impacted, as well as what that transaction did as it flowed across the application stack. The way that you decipher these hieroglyphics are: this is the browser, the URL, the user URL, that's the entry point into the JVM. Now, this particular JVM makes a web service call out to a second JVM that then executes a SQL statement. So this is clearly a database issue, because this SQL statement was responsible for 72% of the response time. And we are focused on time. Time is the currency of performance. It's how end users experience whether things are running slowly or not, and it's a measure of resource consumption. So it's a very handy, it's kind of the single metric that is most important for evaluating performance. Now, when this problem is handed off to the DBA, it's not just a database problem, it's this SQL statement. This is the context I was talking about. And now, armed with this information, I'm able to go in and analyze what's happened. I can see, first of all, the y-axis is time across the day, or excuse me, the y-axis is response time, the x-axis is time across the day. I can drill in, I can see there's a database issue. I see there was 2 occurrences. Go back to that flow, pick up that SQL statement, and go into the expert view where Precise is able to show you what's happening. It controls how long that code takes to execute. And in the database tier, it's the execution plan. And you'll note that Precise picked out the real execution plan that was used at execution time, which is distinguished from the estimated plan, which would be, when the plan was given, but not during execution time. And it may or may not reflect what the database actually did. Now, down here is a response time analysis for the SQL statement. 90% of the time spent in storage, 10% was used in the CPU. I can see the text of the SQL statement as well as a findings report. The text of the SQL statement actually starts to reveal some coding problems. It did select star. That returns all rows from, all columns from the rows that are returned. And so we're returning back additional columns that the application may or may not need. And those columns consume space and resources to process. Now, if you run SAP, one of the big changes, because the HANA database is columnar, is they're basically rewriting SAP to not use select star, so they basically can greatly reduce resource consumption. But this is basically something that happens a lot of time also in homegrown applications, whether Java, .NET, et cetera. Now that screen that this basically shows you who, what, when, where, and why, and the why gets to, like the SQL statement, the execution plan, that allows you to solve problems. Because Precise runs continuously, you can actually measure before and after at the SQL statement level, at the transaction level, so that you can measure for yourself as well as for the application owners and for management that you've solved the problem. So that documentation is really helpful. Now, there's a lot of complexity in these application stacks. Many applications, in fact, everybody we talk to runs at least a portion of the application stack under VMware. And so in this case, you're looking at the customer service application, you're looking at transaction time, and correlated with a slowdown is a virtualization event. And Precise tracks all of the virtualization events. We have a plug-in to vCenter to pick that up. We also are able to detect contention. Contention is different than utilization. We're actually showing when maybe a noisy neighbor is impacting your guest VM in context of the customer service application. And so now I'm able to drill in and get information, and I can actually see the 2 VMs that are contending, in this case, for CPU resources. And so this allows me, once again, to have visibility so that I can basically look at scheduling. I can put a guest VM on a different physical server, all of these types of things that you might respond. And then, in addition to that, I can actually look at the code efficiency to maybe have it use less CPU. And I think I have a pretty good example in this presentation of how somebody was able to reduce CPU consumption by orders of magnitude. So, so that was VMware. Let's go into the code itself, the application code. Precise will actually be able to show you what's happening within Java.NET, your ABAP code, e-business, people code, et cetera. And these are the entry points into, in this case, WebLogic. Down here, there's a findings report that tells me, well, it's these EJBs that you need to look at, and it will tell me, oh, you've also got locking happening on this system. So once again, a deep drill down within the business logic here to show what's going on. Now, in this case, I'm looking at a particular instance. I also support clustering. And so if you have numerous JVMs are running, we can either look at the cluster as a whole or look at bottlenecks within an individual JVM. And I can get into logging. I can get into exceptions. An exception is a little bit different than a performance problem. Typically, exceptions are run very fast, and because there's a logic error, and once you hit that logic error, it ends. Well, we're able to capture a stack trace at the time of an exception. It's going to save a lot of time kind of going through that, trying to figure out what's going on. We just have the stack trace right there. We're also able to capture memory leaks as well. The solution also includes the database tier, and so I can go in, I can evaluate a database instance. Once again, the y-axis is where the time was spent, the x-axis is time across the day. There's a findings report that just automatically tells me what's happening on the system and what I might look at. Now, one of the things about the Precise's findings report is it doesn't just look at logs or wait states. It looks at all execution states, including CPU, as well as returning information from storage. So storage is a very important part of the application stack, especially with the advent of solid state. And so having information along those lines can be very helpful. And so for certain storage units, we can actually drill down and show what's happening at the individual device level. And so that type of information. Once again, it's deep visibility, it's broad in scope to give you just enough information to have more levers to pull as an application performance professional so that you can optimize your applications on an end-to-end basis to meet those business transactions. So I have a couple of case studies I wanted to share with you, and we're kind of cruising along pretty fast. I hope I'm going at an okay pace. And talking about storage, everybody over time changes hardware, and is a hardware warranted? Did it really deliver what the vendor told you? And so we can evaluate that with Precise. So I come in, and what happened here is they basically put in a new storage unit, but when the storage administrators looked just at the storage unit level, they saw a lot of contention, and they thought there might be a problem with this new storage unit. But looking at more from an end-to-end perspective, Precise is able to show what actually happened. We actually went from a throughput of about 400 meg per second, where storage was responsible for 38% of response time, so that's pretty high. With the new storage unit, we actually bumped up the throughput to 600-700 megs per second, so basically doubled, and we're able to cut the contribution of the storage tier to transaction time in half. And I'm able to actually graph that out before, this is the cutover period, and then the after. So once again, documentation to prove that that hardware investment was worth it and it delivered as that particular vendor had expected. There's also, because of the complexity, number of things, there's all kinds of things that can happen. In this case, they actually had a situation where everybody was kind of blaming the DBA, and the DBA was kind of like, well, not so fast. So here we're actually looking at an SAP application, but I think this type of scenario is pretty common. What happened was they were developing a custom transaction for a user, and that user's like, oh, this is so slow. And so the ABAP coder, that's the programming language in SAP, and said, hey, this is a database issue. Well, they ended up opening up Precise. They measured that end user, 60 seconds, so a little over a minute, 53 seconds was spent in the back end. They drilled into the back end, and they actually were able to reveal the SQL statements presented in descending order. And so this top SQL statement, which is responsible for 25% of the resource consumption, its average execution time is 2 milliseconds. So you kind of can't blame the database, hey, not so fast, guys. The question becomes, why are there so many executions? Well, so they bounced it back to the ABAP. He went in, looked at the nesting of a loop, found out they were calling the database in the wrong place. They basically made the change, tested the change, and now the new response time is 5 seconds. A little bit slow, but they could live with that, and far better than 60 seconds. So sometimes just ferreting out, is it the application code, is it the database, is it storage, those are areas where Precise, by having the context of the end-to-end transactions, that's where Precise comes into play. So you basically, kind of end, those things. Let's go. I'm looking at the time. It looks like we still have a little bit of time to go through a couple more of these. And I am streaming through these. This application was under development for over a year, but when they went into QA, they were seeing that the web servers were maxed out 100%, and it looked like the application couldn't run under VMware. So the first thing everybody said was, hey, put this on physical, it can't run under VMware. But Precise actually offered them additional ways to solve the problem. We looked at the transactions. We saw a web service call. It comes in as an ASMX in IIS.net. It actually revealed the underlying code. You see this, what I'm pointing? It says 23 days, 11 hours. Wow, how is that possible? Well, each invocation takes 9.4 seconds, and this thing is invoked 215,000 times, and for every invocation, it uses 6 seconds of CPU. So this is the reason, this code is the reason why this thing could never scale. In fact, it couldn't scale on physical. But what they did is they went back to their developers and they said, can somebody make a change? And so they kind of had a contest, and they tested out the different suggestions, and they came up with a suggestion that was able to run much more efficiently. The new one completed a little less than 2 seconds with 2/100ths of a second of CPU. So now this could scale, and it could run on the VMware farm. And so we're able to basically document that at both the code level as well as the transaction level. This is kind of the before and then the after. And the other thing you can see here in this stacked bar graph that shows web, .NET, and database is now you're interacting with the database. And so this is a profile that you would expect to see for an application that was running kind of more normally. All right, I'm kind of picking and choosing in terms of the additional things I can show you. A lot of people like this because this bedevils many shops. You're unable to meet a business SLA, and everybody's like, help us out. This shop had a situation where the business SLA, if an order is received by 3 p.m., it ships that day. And so it's really vital that they get the orders out, and the warehouse is very busy. Now, this J.D. Edwards sales order screen was freezing, and you can get a very good idea that this is a just-in-time retail inventory management system, and so empty shelves are kind of unacceptable in the retail. You've got to have the merchandise there in order to sell it. So what we did is we dived in, and in this case we're looking at the SQL Server database, but the look and feel is the same whether it's SQL, Oracle, DB2, or Sybase. And we identified this select from PS Prod, and we're able to capture the duration, the fact that it executes so much, and the dark blue matches the keys that says you're not waiting on some wait state or logging or even storage. This thing is bound by CPU. Now, we track this SQL statement by 34301, so every time this is executed, we increment our counters to keep track of it, and that means that we have a detailed history, and I can access it by clicking that Tune button. So here's the History tab, and this screen here shows average duration versus changes. So Wednesday, Thursday, Friday, the average duration was about 0.2 of a second. Very few screen freezes. They're able to meet the business SLA. Come February 27th, something changes, and all of a sudden the execution time is up here, and that's actually slow enough to cause timeouts, which result in screen freezes. Well, Precise, by keeping a detailed history, including the execution plan and journal changes to the tables and indexes that SQL statement used, we were able to pick up that the access plan changed on February 27th. Monday through Friday's bad week. Come March 5th, right, the access plan changed again. This is a good week. This pink star tells us the volume of data. So you can see here the number of rows in the underlying tables is growing, and this is typical for a business. You want your tables to grow, but the thing is that the statements are parsed. The SQL statements come in. The optimizer has to decide what to do, and it chooses one execution plan that's fast. It chooses another execution plan that's slow, causing a screen freeze. So on a deep technology basis, I need to know what that execution plan is, and Precise captures it for me, complete with a date and timestamp. This is the one that was fast and efficient. This is the one that was slow and inefficient. This filter join simply uses a lot more CPU to reconcile, to do this particular SQL statement. They still have the same ultimate effect, but this one basically just has a slower, less efficient recipe for delivering the result set. So, all right, so we stepped through. Hey, do we have time for a couple more?
Yeah, go for it.
Okay. Now, I'll skip ahead. One thing I want you to take a note of, we talked about hardware, talked about SAP, we talked about .NET, we talked about J.D. Edwards in a Java SQL Server environment. This is SAP. Over here, we're looking at PeopleSoft. Precise's support matrix is wide and deep. And so if you have an application, more than likely, we can instrument it and provide this level of visibility. One of the biggest changes that's happening right now is mobility. And PeopleSoft introduced mobility with its Fluid UI. And the Fluid UI uses the system very differently. And so this application is evolving. But the Fluid UI, what it does from a management perspective is it allows the end users to use their phone, and it greatly increases productivity. And if you have, hundreds or thousands or even more employees, if you can increment their productivity, 1%, 2%, it's going to have a huge impact on the payroll and everything else. And so what happened was this particular shop rolled out the PeopleSoft Fluid UI. Now, talking about complexity, this is the PeopleSoft stack. One application, a minimum of 6 technologies, numerous end users. So how do you get started? Once again, Precise is going to be able to follow these transactions. Now, what we're showing you here is a stacked bar graph starting client, web server, Java, Tuxedo database. This is the PeopleSoft application stack. The green maps to J2EE, which is kind of a fancy way of saying WebLogic. This is the cutover. The end users start using the Fluid UI, and the response time goes from maybe 1.5, 2 seconds up to around 9, 10 seconds. What this one screen does not show is the number of people who are not responding. They actually screen freezes in the application. So let's just take a look at some of the visibility that Precise is able to provide this customer. First of all, when I look at the PeopleSoft transactions, you can see that basically we saw this type of thing across the board. All of the transactions were impacted, and as well as all of the locations. And incidentally, when you look at this, you can actually see locations around the world, from Asia Pacific into Europe, as well as North America. And so the performance problem wasn't located to a particular transaction or a particular geographic location, it's system-wide. And so it's kind of a way of saying that the change of the way the Fluid UI was global in impact. And you can see here, from the scalability standpoint, people are trying to do the same type of amount of activity, but the response time basically just degraded. You can see that things are not scaling. Things are going very, very, very badly. Now, over here, when I look at the access count, right, and the concurrent connections, you see something that's very interesting in terms of the access count and the connections. Here, we're only scaling up to about 5,000, and you're looking at about, this tops out at 100 concurrent connections. Now, this is from before, this is after, this is before. So what my real demand on the system, if this thing could scale, is in the 300,000 range. Now, in the old days with the classic UI, you're looking at 30 concurrent connections. So now what this is telling you is that the fluid UI uses at least 10x number of concurrent connections. And so we start to pull back what's happening under the covers with PeopleSoft. And so you can start to see the impact on the web service, the fact that SLAs are starting to breach. I'm not going to go into everything, but what ends up happening is that they basically rely on messaging. It basically exercises web logic and causes queuing within Tuxedo. And so there was actually a multi-tier dependency issue that showed up with the Fluid UI, but Precise was able to show that by a whole bunch of different things that we could basically focus in on what the problem was. It turns out there was also a problem in the database itself. There's actually a messaging log file, and because of all of the concurrent users, that log file was locking. And so I basically had things to tune at every single tier within the application stack. Talk about complexity. There's actually the Tuxedo tier showing you the queuing, and you can basically see the performance degrading within this tier as well. And I can see the processes, I can see the domains and the servers. Now, in Tuxedo, for people who use that, typically what you do is you open up additional queues, domains, and servers, just like at the supermarket, to relieve the congestion, minimize the queuing time. All right, last and final option. Precise shows a lot of information, and as I had mentioned earlier, is every significant transaction interacts with the system of record. So visibility into the database is paramount. Precise shows what's happening within the database, within WebLogic, within Java, .NET, within the browser. But the place that Precise really excels is in the database tier, and this happens to be the weakness of our competitors. So let me show you one of the ways that Precise could help you go through this. I'm not going to spend time on the triangle of database optimization, but we basically are looking at low cost, low risk to wide scope, high risk, high cost type changes. And I'll actually, we'll tweet out this slide afterwards if people want to kind of take a look at it. It's a pretty good guide, I think, for tuning problems. Here's the Precise for Oracle expert view. Top on the findings report is 60% impact is this particular SQL statement. We open up the screen of activity. It shows up there. I can look at the select statement. There's one execution plan. Every execution takes a second. 48,000 executions. So that adds up to 48,000 or hours of execution. The dark blue, once again, is CPU. So this thing is CPU bound, not a wait state, not a log. And I emphasize that because some of our competitors only look at wait states and logging events, but generally speaking, CPU is the biggest execution state and it offers the most buyback. Now, getting into this expert view, and I'm going very quickly, what I did is I looked at the table, 100,000 rows, 37,000 blocks. We're doing a full table scan, yet we have 6 indexes on this thing. What's going on here? Well, when I look at the where clause, what this where clause is doing is it's actually converting a column to uppercase, and it's saying where it's equal to uppercase bind variable. And so what's happening is every time this thing executes, Oracle has to convert this column to uppercase. So rather than do that nearly 50,000 times, it's a lot more efficient to build that index in uppercase. It's called a function-based index. And it's available not only in Oracle Enterprise Edition, but also Standard Edition. And when you do that, what we can then do is verify that the execution plan is using that new index user perm uppercase. That was just kind of my thing. And then from a before and after measurement, they're looking at 1 second execution time aggregates up to 9 hours, 54 minutes with that same exact SQL statement, but having that index built in uppercase. For 58,000 executions, the response time drops down to sub-millisecond. Aggregated together, it comes up to 7 seconds. I basically saved 10 hours of CPU on my server, and this is huge. because if I'm not due for a server refresh, I'm able to live on that server. I actually drop CPU utilization by like 20%, and you can actually see the before and the after. And so that's the type of visibility that Precise can provide. And there's also some additional things that we might look at, like, well, why do you have all of these indexes if they're not being used? We can follow up with that. Here's brief architecture, and I will wrap it up because I see we're reaching the top of the hour. I'm a true believer in this solution, and we want you to be a true believer. At IDERA, we believe that a trial makes a customer. So we if you're interested, we are willing to do evaluations in your site. So with that, I will pass the baton back.
Yeah, this has been tremendous detail that you showed there. I mean, it's really quite fascinating. I think I may have mentioned to you in the past, and I know in some of the other webcasts we've done with IDERA, I've mentioned that I've actually been tracking Precise since before it was acquired by IDERA, all the way back to like 2008, I think, or 2009, and was fascinated by it back then. I'm curious to know how much work goes into staying on top of new releases of applications. Like you mentioned SAP HANA, which I think is pretty impressive, that you can actually dig into the HANA architecture and do some troubleshooting there. How many people do you have? How much of an effort is it on your part? And how much of that can be done somewhat dynamically, meaning when the tool gets deployed, you start crawling around and seeing different things, and how much of that can be dynamically sort of ascertained by the tool such that you can help people troubleshoot complex environments?
You asked a lot of questions there.
I know. Sorry.
I did provide a lot of detail because for these applications and looking at the code, really the devil is in the detail. You have to have that level of detail to really be able to have something that's actionable. Without actionable metrics, you just know about symptoms. You're not actually solving problems. And IDERA is about solving problems. Now, staying on top of the new releases and stuff is a big challenge. The question of what it takes to do that, that's really for product management. I don't have a lot of visibility into the team that basically keeps us up to date on things. In terms of HANA, that's actually a new addition to the IDERA product line, and it's very exciting. One of the things with HANA is that well, let me just talk about the past for a second. In the past, what SAP shops would do is they'd replicate the database for reporting purposes, but then you'd have to have people reconcile to what's actually current. And so you'd have these different databases, and they'd be kind of out of sync by different levels. There's just a lot of time and effort, plus the hardware and software and people to maintain all of that. And so the idea of HANA to have a highly parallel in-memory database is to basically avoid the need for duplicate databases. You have one database, one source of truth. It's always up to date, and so that way you avoid the need to do all of that reconciliation. And so the importance of the performance of the HANA database goes up, I'm going to say 10x, or at least more valuable than the sum of all of those other databases, hardware, resources combined. And so being able to manage HANA. Now that component is actually in beta testing right now, and it's something that's going to go GA soon. So that'll be something pretty exciting for IDERA and for us to basically support the SAP platform. So I'm not sure what other parts of your question I kind of shortchanged, but
no, that's all good stuff
in there.
Yeah, I threw a whole bunch at you all at once, so sorry about that. But I'm just fascinated. I mean, really, this is not it's not a simple application, right? I mean, you're digging deep into these tools and understanding how they're interacting with each other, and to your point, you have to kind of piece the story together in your head. You have to combine bits of information to understand what's actually happening and what's causing you the trouble, so you can go in there and solve those problems. One attendee is asking, how difficult is it to implement Precise? Another person asked, who are the people? Obviously DBAs, but who are some other roles in an organization who would use this tool?
So Precise is a little bit more complicated to deploy. You do have to have some knowledge of the application environment in terms of, this application runs on this database, and these are the middle tier, these are the web servers, et cetera. But I think given the complexity of some of these applications, it's actually relatively easy. If I can instrument the web server's middle tier database, I can give that end-to-end. You notice that I didn't say anything about instrumenting an end-user client, and that's because what we do is we actually include dynamically, so you don't have to change your code or anything else, a JavaScript that goes into the application page frame. So no matter where a user is in the world, when they access the URL from your application and they bring down that page, it comes instrumented with Precise. And that allows us to pick up the user ID, their IP address, also the first byte rendering time of each of the page components, script execution time within the end user browser. And so in terms of the transactions, you don't have to map out the transactions because they're tightly coupled. This URL becomes an entry point into JVM and then invokes these methods, resulting in a JDBC called the database. We're able to basically capture those natural connection points and then present them to you in that transaction screen that I showed you, where we also calculated how much time or the percentage of time that was spent in each individual step. And so all of that is done automatically. Generally speaking, we allocate 90 minutes to basically install the Precise core, and then we start implementing the application. Depending upon the knowledge of the application, it may take us some additional sessions to get the entire application instrumented. Many people use just the database component of Precise, and that's fine. You can basically break it up into the components that you feel like your site needs. We definitely believe that the context of having the entire application stack instrumented, so you can basically see that tier-to-tier dependency, it actually magnifies the value of monitoring an individual tier. So if anybody wants to explore instrumenting their application stack further, please go to our website. I guess that's the easiest way to request additional information, and we'll discuss it a little bit further.
Yeah, and let me just throw one or two quick questions over to you. I am guessing that you are collecting and building up a repository over time, both for individual clients and as a corporate entity overall, of interactions between various applications and various databases. In other words, scenario modeling is, I guess, what I'm alluding to. Is that the case? Do you actually maintain a sort of repository of common scenarios such that you can make suggestions to end users when certain things come into play, like this version of e-business suite, this version of this database, et cetera? Do you do much of that?
Well, that type of information is built into the findings report. The findings report says what are the performance bottlenecks, and it's based upon execution time. And then there's a part of that findings report is, learn more and, kind of what do you do next. And so the information or the experience from customers and so forth is basically incorporated into that library of recommendations.
Okay, that sounds good. Well, folks, fantastic presentation today, Bill. I love how much detail you had in there. I just thought this was really fantastic, gritty, granular information showing how all this stuff is done. And, it's at a certain point, it's almost like black magic, but really it's not, right? It's very specific technologies you guys have put together to understand very, very complex environments and make people happy, because no one likes when the applications run slowly. Well, folks, we will archive this webcast. You can hop online to Techipedia or InsideAnalysis.com. And, wow, thanks for your time. We will catch up to you next time. Take care. Bye-bye. All right.